So checking with our customer service rep for CEngage, they said that you shouldn't have to have registered with a school account. You ought to be able to use any account, whatever. You just want to, two things to do. One is to log into CEngage on the same browser before you access the link to it. What do I mean by that? Well, when you go into our canvas and you click on the modules and you can find the link, as I was walking you to do that way, go ahead and log into CEngage first, and then go to Canvas and log in there. See what that does. If it doesn't work, snap a picture of the error message and text it to me, and I'll email it to her, and she'll get it, help us get it taken care of. So we'll find out, right? Find out if that works or not. All right, so we were talking about data types. First applications of computers were to crunch numbers. That's why they were invented, either to help create artillery table charts or do nuclear weapon calculations or to crack codes or whatever. The use of numbers in many applications is still important. One of the data types we play with are integers. Integers are whole numbers. They say here that an integer's typical range is there's a typo there. That one's not supposed to be there. 2 to the power of 31 to 2 to the negative power of 31. Well, let's see how big those numbers really are if we can. What is 2 to the power of 31? Not s to the power of 31. How about my fingers work? Let's go there. All right, great big number. That's about 2 billion. And honestly, I don't think that's accurate at all. I think that integers in Python can get much larger than that. This is a common limit to integer data because it's 4 bytes. It's a 4-byte integer. If we did the 1s and the 2s and the 4s and the 8s and whatever, then that would wind up being 31 bits of data. Why not 32? Because a byte is 8 bits. Well, because that very first bit is used as a sign bit. And if it's not set, then the number is positive. And if it is set, then the number is negative. So that's a 4-byte data type, and I don't believe that Python does that. I think we can hold numbers much larger than 2 billion in idle. Now, in those other languages, there are other types of integers that you can use that are 8 bytes, which can hold vastly larger numbers. But if I pop open the shell, if I just type in idle to pop open the shell, and I do this, x equals, and I'm going to type in, I don't know, like 12 zeros. Let's go for a trillion rather than a billion. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I tell it to print x. Boom, it works perfectly. So I don't know what that slide's talking about. Python integers are different beasts than they are in other languages. They can hold much larger values. What if we say x equals x to the... Okay, this is not going to work right. Well, we'll find out. If we take 2 trillion and we square it, what's it going to be? Huge number. It did work, right? So clearly that limit that that page is talking about does not exist. Maybe it was true for Python 2 or something. It's certainly not true for Python 3. So integer literals are written without commas. Well, whenever they say literal, they mean the number that is actually in the code, right? I typed that in. That's a literal. That's a literal. This is just saying that if I try to type in x equals 1, comma, 0, 0, 0, well, let's print out what x is. But it's certainly not 1,000, right? So putting the comma in there did something to it. So you don't put in commas in an integer literal or a floating point. What's a floating point? A float is when there's a decimal involved, like this, right? Again, you would not put a comma in there. You would not say 2000.12. That turns it into something completely different. Turns it into what's called a tuple. It's 2 numbers chained together. We don't care about that now. So a floating point number uses decimal points. Now it says that Python's float typical range is from negative 10 to the power of 308 to 10 to the power of 308, or in other words, a 1 followed by 309 zeros. Now that I can buy. That would be an 8-byte data type, which is the same kind that's used in C++ and Java for floating point numbers. Let's see if we can get larger than that, though, just out of curiosity. If I go to idle and say x equals, can I do this? I wonder if that'll work. Nope. Okay. So yeah, I hit the limit. I hit infinity. What does this syntax mean? Oh, my mistake. I didn't type the equal sign. X equals 1e to the 307. Then I print out x. All right. So that slide is actually correct. The limit is a 1 followed by 308 zeros. That's a pretty big number, right? Or point followed by 308 zeros and a 1, right? So quite a range involved there. Well, this notation here, 1e, I'd already told y'all, I think that that's how you take something to the power of something else. That's 2 to the power of 3. But you can also enter exponents, like the Avogadro's number, which I've just about forgotten. Shame on me. Is 6.022 times 10 to the something. 23rd? Yeah. Yep. So, if I was going to do my chemistry calculations and I needed to do that, I might say A is equal to 6.022 exponent 23. That just means times 10 to the 23. It's like the E key on your calculator. It doesn't mean taking it to the power of 23. It means multiplying it times 10 to that power. So then when I print it out, if it had printed it out in integer form, we would see a 6 followed by 23 zeros. So that's just scientific notation. So a floating point number can be written either using decimal notation or scientific notation. You feel like using that E notation, you're familiar with it, you want to use it, that's fine. Otherwise, you can always just type in its decimal equivalent, right? 0.378 works just as well as if you had typed it in like that. Now my brain usually quite often works like this, and so you'll usually see me do that, but if it's got a whole bunch of zeros in front of it or after it, then it's easier to use the scientific notation. So character sets. Did we pull up ASCIItable.com and look at that last week? Okay, so Python can tell you the ASCII value of these characters if you want. Say I asked you on a quiz, you're going to fail if you can't tell me the ASCII value for capital A. I'm not going to do that. But if you wanted to find it out, you would type in ORD, parentheses, in parentheses, and inside those parentheses, you type the double quotes in, and inside the double quotes you put in a capital A, because that's the number that we're curious about. And it tells us that the ASCII value of a capital A is a 65. Which would mean that a B would be a 66, a C would be a 67, a lowercase a, would be 32 beyond a 65, and a B would be 32 beyond 66, and a lowercase c would be beyond a 37. How about a tab? ORD, parentheses, quote, \t, end quote, in parentheses. 9. Okay, I can believe it. What if you needed to go the other way? What if you had this number and you needed to turn it into a letter? You can use CHR. You could say, I want to know if I have the ASCII value of 65, what letter that's equivalent to? And sure enough, it's an A. And if I did a 97, CHR 97, it would show me that was a lowercase a. Alrighty, so I'm going to go ahead and actually create a lecture file. I believe we're on lecture E, so get to it. So what did I do? I did in the shell, I did file, new file. I'm going to do a save as immediately. Save it to my favorite programming directory of the desktop, call it lecture E with no spaces. CIT1203 Lecture E, Chapter 2. And I believe this is February 4. All right. So, here's something I want to try out. I'm going to say that A is equal to capital B, like I'm going to spell out the word Bob. And I'm going to say that B is equal to a capital O. And that C is equal to a capital B. What would happen if I turned those into their ASCII values and then added 1 to them and then turned them back into characters? I'd be shifting them down the character set by 1. Well, let's see if we can figure out a way of doing that. How about this? This is going to look nasty, but let's just roll with it. A is equal to CHR, parentheses, not all those things, parentheses, ORD, parentheses, A, close parentheses, plus 1, close parentheses. And then just copy and paste that and change those A's to B's. And then do it again and change those B's to C's. So A equals the character value of the ordinal value of A plus 1, B is equal to the character value of the ordinal value of B plus 1, and C is equal to the character ordinal C plus 1. So if we work from the inside out, what's this doing? This is turning that letter, which is a B, into an ASCII value, which is 66. It's adding 1 to it, which turns it into a 67. And then we convert it back to an ASCII character, and we're ready to print it out now. So that 67 gets turned into a capital C. And 1 past an O is a P, and 1 past a B is a C. So it's going to print C, P, C if we printed it out, which I feel like doing. Print, parentheses, A, comma, B, comma, C into parentheses. So when I run it, I'm going to just click F5 and run it. And so instead of printing BOB, it printed CPC. This is an example of what's known as Caesar's cipher. So imagine, back in the Roman days, you want to send a message to your troops, but you don't want your guy to be able to be caught and have the instructions, stolen, and so that the enemy knows what you're doing. What you could do is you could write in a message, right? Don't type this, right? Attack at dawn, right? Or maybe we just take all those bases out. Anyways, and then you would modify each letter by a certain value. You might raise an A to a B. 1 past a T is a Q. 1 past an A is a B. 1 past a C is a D. 1 past a K is an L. 1 past an A, B. 1 past a T, your STU. What's 1 past a D? E, B, W, X, element, no, right? And so That's the message that you gave to your runner, and he ran to, you know, tell your waiting legions to attack at dawn. And if he was caught, hopefully the bad guy wouldn't be able to figure out that that said attack at dawn. Well, you didn't only have to shift it by 1. This is everything shifted by 1, but you could have shifted by 2, right? You could have gone +2, so A to C, and C to D to E, right? Like that. That's called Caesar's cipher. It's not really a code. You know, I don't know. Maybe it is a code. I've forgotten the difference between a cipher and a code. But
ciphers, there has to be a bijection from plain text to the encryption text. A code is blah blah make believe. You can just make up as you go.
Okay. Okay. So we shifted everything by 1 to try to make it less readable, and then to make it more readable, you would shift everything back, right? A B minus 1 is an A, a Q minus 1 is a T, a Q minus 1 is a T, and a B minus 1 is an A, and so forth. And this book shows some code for writing a Caesar cipher. And eventually, one of your projects, the second half of the semester, what I'll do is I'll publish a list of projects, and you can pick one that you want to write, or you can come up with your own, and one of them is that's available is to do a Caesar cipher. However, since the book gives you code for a Caesar cipher, then I make the rules a little bit more specific, and I ask you to do a different kind. The different kind would be, what if you would modify this value by 1, but you modified this value by 2, this one by 3, and this one by 4, right? That's a kind of cipher. Another cipher is if you modify the letters of 1 by a different word, the distance between those two letters, and then that word repeated over and over and over. So what is an expression? Expression is pretty much anything that we can put on the other side of a variable assignment. That's an expression. The simplest expression is just a literal, right? But we don't normally think of that as being an expression. But it is. So is that. So is, you know, here's an expression, y is equal to x times 3. Here's an expression, z is equal to y times x plus y star 2 in parentheses, right? Anyways, these are all expressions. These are growing in complexity. They're not that bad yet. As we mentioned on Thursday, you do have to worry about operator precedence, the order of operation, meaning exponents are done before anything else, and addition and subtraction is done, multiplication and division is done before addition and subtraction. And parentheses cause the things inside the parentheses to be evaluated first. Now, since I don't know we could figure out what these are. So what is what is 1 plus 3? That adds up to 4. What is 4 times 3? 4 times 3 multiplied together is 12. And then if I was going to solve this one by hand, get some paper out or something like that, here's about how I would do it. I would replace all the y's with 12s and the x's with 4, right? And then I would try to do it by the order of operator precedence, which we talked about being PEMDAS, meaning you do your parentheses first, you do your exponents first, then you do multiplication and division left to right, and then you do addition and subtraction left to right. So here's an exponent. We'd have to do that first. And 12 to the power of 2, 12 times 12 happens to be 144. I'm glad the number was that small. And then we would do what's inside the parentheses. So 4 plus 144 is 148. And then left to right, since there's no more parentheses and there's no more exponents, we would just add those two numbers or multiply those two numbers together, and we'd get whatever that is. I have no idea. I'm not going to bother figuring it out. Oh, why not? 12 times 148. 1776. All right. Right. So, the computer, the interpreter, will take these expressions apart in their operator order in order to figure out how to solve them. Just like if you had a scientific calculator and you typed in an expression, you might have to use parentheses to get certain parts of it to happen first. Whereas if you bought the $5 one, from Dollar General, then it might not, right? You might not be able to control the operator, the order of operations, and it might just do them in the exact order in which you enter them, rather than doing the algebraic, the accepted rules of order. So expressions provide easy way to perform operations on data values to produce other values. That's the real point, is an expression is, evaluates to something that can then be stored as data and used. So when entered at a Python shell prompt, the expression's operands are evaluated, and then it computes the value of the expression. So back at the shell, if I do run Python shell, if I type in 1 plus 2, prints out 3. So if I did x equals 1 plus 2, that 3 is going to get stored into x. So this is the expression itself, and this is the assignment of that expression into a variable. So most of these we already are quite familiar with, having done addition since kindergarten or whatever. Addition is a plus sign, subtraction is a minus sign. And I'll be childish and say minus rather than subtraction, A minus B, right? Rather than say A subtract B, I'd rather say A minus B. A plus B, A times B, A divided by B. Got a couple of new ones here. That means divide and round down. It's called floor division. This textbook calls it quotient. All right. And then a minus sign all by itself without another number in front of it is called negation, and it just flips it to be the negative of it, right? Just like if you type in -3, we think of -3 as being a value, but how the computer sees it is 3. Oh, I better flip it to be negative, and then it becomes -3. So if I go to the shell and type in 5 divided by 2, that's 2.5. But if I type in 5//2, that's the quotient. That's the floor division. It rounds it down. And then there's modulus, which means remainder. When I divided 2 into 5, it went in there 2 times. But there was something left over. And that left over was 1. So if I do 5 modulus 2, its remainder is 1. 6 modulus 2, well, 2 goes into 6 3 times, but there's no remainder after that. And so 6 modulus 2 is going to be 0. If you have 10 divided by 3, well, 3 goes into 10 3 times, but not evenly, right? There's something left over. What's left over? 1. So out of all of our symbols, you know these. I'm not going to even bother giving them names. Hopefully you know addition, subtraction, multiplication, and division. But then you also have floor division. They call quotient. And then you have modulus, which means remainder. And then there's star, which means exponent. I don't know why languages don't use the shift 6, the up arrow, the caret, to mean to the power of. But they don't. Most languages don't even have an exponent operator, and you have to use a math function in order to accomplish the same thing. So we did this, print 7 divided by 2, that's going to be like 3.5. If we do 7 modulus 2, or let's do a floor division, quotient, 7//2, well, 3.5 divided by 2 rounded down is 3. So this is going to give you 3.5. That'll give you 3. 2 goes into 7 3 times with a remainder of 1. So if you do 7% 2, 7 modulus 2, that's a 1, because 7 divided by 2 has a remainder of 1. And why not use to the power of just to tie things up? And so 7**2 means, get rid of that underscore there. 7**2 means to the power of 2. 7 squared. Yeah. I'm going to pause here and make sure that anybody who has syntax errors gets help correct. Now, this is the kind of thing that starts giving me lack of confidence in the book, but I swear it's the best book for this class that we found so far. Unary negation is evaluated after ... I don't think so, because if I did this, print 2 to the power of -3, it better do that part first before it starts to try to take it to the exponent. Anyways, in general, the rules are that
could they possibly refer to like -2 cubed? Because then it should prompt for -8. Or if you do -2 squared, you should get back 4. So yeah, so I think what they mean there is that powers have the highest priority in the negation. So if you go -2 squared, you're not going to get back 4. You should get back -4. I think that's what they're talking about.
that sounds right. If we did print that, yeah,
Well, then just
yeah, so.
I can't keep my Python to run right now.
So in general, the rules, the important ones, are to remember that multiplication and division happen before addition and subtraction. And if you get that, then you pretty much get the whole thing. That's the important thing to remember. And operations of equal precedence are left associated, meaning that they are done left to right. There's one exception, 2 exceptions. The equal sign is right association, meaning that you do the right side first, you get that value, and then it gets copied into the left. And you certainly can use your parentheses to change the order in which you get parts of the expression evaluated. So if you give mixed types, if you give the same type in an expression, like 2 plus 2, the result is also going to be an integer, right? 2 is an integer plus another integer is going to give you an integer. But when the operands are of different types, the resulting value is the more general type. That's a weird way to put it, but if you're going to take 2 and you're going to add plus 2.5, you're adding an integer to a floating point number. And if the result was going to be an integer, that meant that something got lost, right? 2 plus 2.5. You don't want that 0.5 to be lost, so it gets stored into a float. Other languages call that automatic promotion of types, to where the least precise type will get promoted to the higher precision type in order for data not to be lost. There. That's how I feel about this slide. Lies. Don't believe it. The cake is a lie. Why is it lying? Because 3 divided by 4 is not 0. In some languages it is. It's like they took a C textbook and... Anyways, if we type in 3 divided by 4 into our code, print 3 divided by 4, it's not going to be 0. That's what / is for. If you want to do that division around down, there you go. So mixed mode arithmetic involves integers and floating point numbers. You must use a type conversion function with working with input of numbers. What does that mean? Well, when you get input from the keyboard, it's not a number yet, and if you want to do math with it, then you better convert it either into an int or a float. X equals float parentheses x, I'll turn it into a float, or x equals int x, I'll turn it into an integer. I usually recommend to turn it into a float so that if the user's typed in a decimal point, then it doesn't break it. There's a third conversion type, which is the str function, which will take something and convert it to a string. Why would you want that?
You're dealing with, say, intervals versus actual numbers.
Yeah, there's all sorts of times when you might want to convert something to a string. What if I had this? What if I said x is equal to 3, and I wanted to be able to print a message that looked like this? X equals, in quote, comma, x, but it put that space there. What if I didn't want that space there? There's no way to disable that space. There's no magic thing that I can say here to convince it to not turn that comma into a space. But what I can do is to say this, and then not use a comma, but instead say I want to append something to it. But if I have a string and I want to append something else to it, it better be a string as well. And now when I do that, it takes a space out. So if you ever want to do your output in a form where there's the commas are not being turned into spaces, this is one way to accomplish it. There are other ways. There are ways that I would probably veer towards rather than doing this. And I may as well show them to you, but I don't want to spend a lot of time on it right now. If I did this, print, parentheses, quote, x equals %d, that's a placeholder for what's coming up next, end quote, %, x. Now that equation, that looks totally weird, and I'm sorry it does. Some languages do this as printf, and they would not use that % here. But anyways, that would print it out. What this is saying is that this is our formatting string, and whenever it hits a %, it's a placeholder. And this kind of data is an integer, so it's going to use %d. If this was supposed to be a floating point, we would use %f. So if I change that to an f, it'll probably print 3.0. Or, okay, fine. 3 followed by 6 zeros. If I wanted to print it out to 1 decimal place, right, like 3.0, I could say %1f, which means a floating point with 1 decimal place. Haha, I goofed that up. Let's try that one more time. It should have been %.1f. That's why I'm not going to make you memorize these yet. But there we go. This would print it out to 1 decimal place. % means this is a placeholder. The dot means, oh, by the way, I'm going to tell you how many decimal points you want to play. I know that's not the 100% accurate way of describing it. I want you to show me one number after the decimal place, and then it's a floating point data type. And so when I do that, it prints 3.0. If you wanted to print out dollars and cents, it's nice to have 2 zeros there, right? because that's how we think, you know. I have 21 pennies, or I have no pennies, or whatever. We usually print our dollars as looking like this, right? But we usually like to have dollar signs in front of them. So if I was going to print a cost value, I might make it look like this. I might want a dollar sign in front of my placeholder so that it'll print dollar sign 3.00, like that. That's cool enough that I might actually type it into our code. Handy way to print dollar amounts. Let's say that price equals $32.50, 32.5. And so printf, nope, that's C. Print, parentheses, quote, price equals, tell you what, I'm going to make that a lowercase, dollar sign, and now I'm going to put in my placeholder, which is at the end, it starts with a percent. Percent dot 2, meaning I want it formatted with two digits after the decimal point. It's a floating point number. End quote. So percent dot 2f, end quote, percent sign, price, close parentheses. If that catches on with you immediately and you feel like using that in some upcoming homework, that's totally cool. If it doesn't, that's also totally cool. I just realized that I'm seeing what looks like it might be the limit for the camera. And so the camera's either cutting off the first couple of pixels or the last couple of pixels. Yeah, I'd rather cut off the first couple. So, if you use INT, it truncates the data, meaning it chops off the last part, meaning that it rounds down. So if you do 6.75 and you convert it to an integer, it's not going to turn it into 7. It's not going to round it up. It's going to round it down. But if you use the round function, then it will follow our normal rules of rounding. And when you're using a round function, you can specify if you want it rounded off to a whole number or to a partial number. Like if I have this, if I type in round 1 divided by 3, well, 1 divided by 3 rounded down is 0. But if I do round 1 divided by 3, comma 1, it's going to display 1 place after the decimal. And if I do the same thing, 1 divided by 3, comma 2, it displays it to 2 decimal places. Even if it's a whole number, right? Even if it just has to display zeros there. If I say round the number 10 to 2 decimal places, oh, I lied. It is rounded to 2 decimal places, but it's presenting it as an int. If I did that printf thing, right? If I did that print with the placeholder, then we'd actually see that there were 2 decimal points there. You do round 3.14159, comma 3, and it's going to round this number to display with 3 places after the decimal. So it'd probably say 142. That's my guess, is because a 5 is, gets rounded up like that. So you get to control the precision of the numbers that you want when you use the round function. Whereas if you did an integer call, integer of 3.14159, it's just going to chop off everything after the 3. Boom. Just like that. Doesn't matter if you do this, int 3.99, right? You'd think that's just about 4. The int function doesn't care. It drops off everything after the decimal point. That's called truncation. Okay, so this is reiterating the use of the str function in order to produce nice output. If I have this, x equals 35, and I want to say print, parentheses, quote, $, end quote, plus 35, that's not going to work. It would want me to convert, oh, that was supposed to be x there. Still wouldn't have worked. It would want me to convert x to a string, or to use that other syntax with the placeholder. So I could do print, parentheses, quote, $, end quote, plus str. Please convert what's coming up to a string, and then it displayed OK. Or you could just do print, yeah, I can't see it now. Print the $, comma, x, and for some reason it's able to convert this to a string automatically in order to print it out when you do it with a comma. But like I said, whenever you do a comma, it puts a space in the output. Not going to count you off because there's a space between your $, and your numbers. I'm not going to force you to worry about that. But if you do want that fine-grained control and you feel like using the str function to turn a number into a string so that you can print it out in that format, that's fine. My preference would probably be for you to learn the placeholder syntax that I showed you, where you use that % for a placeholder. And you will see me veer towards using that more and more as we go along. There's an alternate of that was introduced in Python 3, and honestly I don't remember it that well, so I tend towards the other format. They both work just fine. So Python includes many useful functions which are organized in libraries of code called modules, and you can write your own modules. Here's an example of a Python module, Python library. Down here underneath all that, okay, good. It's working for me. I haven't checked to see recently if everything's working for you. Do this. Import turtle with a lowercase t. And then do t, or let's call our turtle Leo, equals turtle all lowercase dot turtle with an uppercase, parentheses in parentheses, and then I'm going to tell Leo to go forward 100 pixels. Leo.fd, or the whole word forward. People always miss R's and stuff like that, so I'm just going to use the abbreviation FD. Go forward 100 pixels. So Leo.fd, parentheses, 100 in parentheses, and then Leo.right, R-I-G-H-T, 90 degrees, so parentheses 90 in parentheses, and then go forward again. Leo.fd 100. So when I run it, this imports the turtle module, the turtle library. And what is a turtle? It's a graphic object that can be controlled on the screen by telling it to go left, right, forward, backwards. Like that. Back in olden days, see if I can get a picture of it. Look like that, right? It actually was a gadget that had a pin, and you could tell it, go forward, turn left, turn right, and yeah, it had this electrical cable that hopefully, it wouldn't get, all caught up in. You could certainly do things like this a lot better now, right, with some kind of Bluetooth connectivity or whatever, but it was a mechanical turtle, the logo turtle, invented back in 1969. So we could tell our turtle when to lift the pin, when to put it back down. We could change the pin's color. We could change the width of the pin. Let's make our turtle draw a circle. Fortunately, that's easy. Leo.circle, and I want you to draw me a circle with a radius of 50, so parentheses 50 in parentheses. All right, and so he did. And then we could tell him to fill the circle. Right. We'll play with turtles after a little while. But this is showing the power of a library. There's no way that I could write code that would display graphics on the screen like that in just 3 minutes, right? Because this is complicated stuff, right? I mean, it doesn't look complicated, but imagine if you had to do it just starting from the ground up, right? I don't know how to address pixels on the screen and to turn them off and to turn them on and to do the math so that I could draw a line that was going at this angle rather than this angle, stuff like that. So it's really nice to have a graphics library, and there's way more than one graphics library for Python that lets you do that. Now this is a testing thing, right? You're not going to write a video game using a turtle graphics library, but it's useful for understanding concepts. Like we can display loops and function calls and stuff like that, and kind of have them draw things on the screen and tie the concepts together. So that's an example of a module, the turtle library. A more normal one might be the math library. You're not going to show us that? Yeah, here we go. If we import math, then we can get a hold of pi. That capital letter there doesn't look good to me. I don't think that's going to work. But let's go to our code and import math. And then say area, or let's do a radius, r equals 3, and then area equals math.pi times r star star 2, r to the power of 2, right? Pi r squared. That's what we're doing there. And let's print out the area. Print parentheses quote area equals end quote comma area. Now every time it runs now, it's going to be popping up that turtle window that I'm going to have to close to get it out of the way. But we did see that it printed out our area there. Okay. Printed out to a whole bunch of decimal places. I might want to narrow it down so it's only like printing 2 or 3 places, in which case I'd use that syntax I showed you with the percent sign, %.2f or %.3f in order to, make that display prettier. So in the homework, if I ever ask you to calculate the area of something, if you feel like using 3.14159 for pi, that's fine, but you probably really know that pi is a much larger number than that. I mean, much more precise, infinitely precise. And it looks like, right, that's just a small fraction of its billions and trillions and infinite number of digits that it's got in it. So, if you're supposed to do a calculation involving the value of pi, it's better, it's cooler, it's more precise to import math and then use math.pi. And then you go, I don't like typing in that math dot in front of everything. I just want to type in pi. But there's an alternate syntax of the import function, of the import command. From math, import pi, and then you can just print pi like that. What this says is I want you to go into the math library and bring in this function or this variable and let me address it without prefixing it with the name of the library. And so what all comes with the Python math module? Let's look up Python 3 math module. All right, it's got one called ceiling, which rounds up. Got FABS, which is the floating point absolute value. It's weird. Is there also just a regular ABS? So if I type in import math, and then I say math.abs of -7. Well, the absolute value of -7 is 7. You remember what absolute value means. It just means drop any negative sign that might be on there. And then I blew it up, so it must really need to be FABS. Math.FABS, parentheses, -7 in parentheses. There we go. Right, it converted it to a positive number. It took the absolute value of it. What if I wanted to use this FABS and I hated prefixing it with that math word? Then I would do from math, import FABS, and then I could do FABS parentheses -7, and it would do the same thing. Now, honestly, I don't mind typing math dot in front of my math function, just like I didn't mind typing turtle dot in front of my turtle function to get it to start drawing. But if it does bug you, if you don't want to put in the module name in front of the function names, then you have this alternate syntax of importing it. Whoops. Sorry, gang. Run something. So let's at least speed it up. I'm going to add a line to my turtle code right here that tells it to draw it as fast as possible, which is to do leo.speed parentheses 0 end parentheses. Any non-zero number puts a delay in it. I forget what the default delay is, but 0 removes all delay whatsoever. And so now it's going to draw the right as fast as possible. So at least, you know, since we're going to keep running our program, we don't have to wait for the turtle to draw it each and every time. So when we were printing out our price, the various components of this placeholder, the only ones that were an absolute must in order to get it to display something would be %f. Don't necessarily make that change because I'm going to wind up undoing it all, right? And so making it %f, printed out that number like that. But I wanted to exert more control over it. I wanted to be able to specify the number of decimal places, so I put .2 there to display 2 places after the decimal. And then my price was that. And then just to indicate that it was $1, I put a $sign in front of the whole shebang, right? So that's why we had $sign. It looks kind of like code. %.2f. That just formats it nicely as a dollar and cent amount. So from math, import pi, sqrt, which would mean square root. And at that point, we could print out pi, square root of 2. If you want to import all the modules from a library and be able to use them without using their library prefix, you can do from library import asterisk. And that works 99% of the time, but we'll get to one that it doesn't work for. So if I want to use the square root function, since I've imported math, I can do so, right? Print math.sqrt, let's assign it to a variable. X equals math.sqrt parentheses math.pi in parentheses. So the square root of pi. Now if you're ever in a language that has the exponent built in, like this one does, but not the square root, a quick hack to avoid having to import a function in order to do the square root is just to take that number to the power of 1/2. And to get a cube root, it's take it to the power of 1/3, and so on. So if I had done this, y is equal to math.pi star 0.5. Those values are actually the same thing. It's just kind of like math trivia. Print parentheses x comma y, and it's going to print out that number twice. Hopefully they're the same. It should be. Yep. So what did this do, right? This imports the math library. That line did that. What did this one do? Imports pi from the math library. which lets us skip the math dot prefix. That's why we were able to just do print pi rather than print math dot pi. I could have also have imported square root, in which case I would not have had to do math dot square root. I could have just done square root. So that would be the next thing we demonstrate. It's just from math, import asterisk, and now I can use any function in there. X is equal to the square root of pi, right? I don't mind typing the math dot part. So normally I would tend towards doing it like this and then prefixing everything with math. But I gotta admit, it makes the code look nice and clean if I can just type in pi and square root. So what did this one do? Import all functions from math library, which lets us skip the math dot prefix. I guess I could copy and paste that comment if I felt like it. If you ever see me copy and paste a comment, please don't type it in by hand. Unless there's a really good reason why copying and pasting doesn't work for you. So after you import a main module, you can view its documentation by running the help function. Give us a description of that. Well, I hope the book goes into further detail. Because if I do this, nah, I can even try to figure out what they're trying to tell us there. So the program format and structure. It wants us to start with a comment with the author's name, the purpose of the program, and other relevant information in a doc string, meaning they want us to use a very specific format, which I guess I should start. Come on. Like this. This is how they want us to do it, rather than doing it as how I have done it. I don't care so much about doing it this way, but if we did define our own functions that we wrote and we docstring them like that, then it would set it up in such a fashion as I do believe I showed you this. If you type in dir, well, import turtle, and then I do dir turtle, it'll tell me stuff that the turtle can do. These are all the functions that you can call that were imported from the turtle class, from the turtle library. Right, so I typed in dir. If I wanted help on a specific one, I could probably get it. What happens if I just type in help, parentheses, turtle? Does that display anything useful? Precious little. How about if I do help turtle.setup? There it gives me some information. This is a doc string that was attached to that function. So when I typed in help turtle.setup, all of these are comments that the programmer who created the turtle library added to the setup function in there. So these are all comments that are attached to that function. How about import math? And then I do help math.sqrt. Except I need to remember to put my parentheses. Math.sqrt. Tells me what it is. Square root. Returns the square root of x. Help, parentheses, math.fabs, in parentheses. Returns the absolute value of the float x. Here I wonder what they're trying to tell us by this syntax. Comma, followed by a slash. Yeah, I didn't think so. That could be telling us that there's only one parameter, that we only feed one argument into it, but I'd have to then know a function that took 2 arguments to compare that with. So a function is a chunk of code that can be called by name to perform a task. Quite often a function requires arguments, parameters. They're called arguments when you're passing a number in. They're called parameters when you're writing the code that receives that value. The argument may be optional or it may be required, depending upon how they wrote the function. If we call the square root function, the argument is required. Otherwise, it's the square root of what? When a function completes its tasks, it might return a value back. So when we did x is equal to float, or excuse me, x is equal to the square root of pi, it calculated the square root and it returned it back so it could be stored into x. To learn how to use a function's argument, use the help function. For example, the round function. If I come here and do help round, see, this one doesn't display like that. Anyways, okay. So, rounding it, you can round a number and you can specify how many in digits, what the precision in decimal digits is. But its default is no digits. So you can leave this one off. If you see an equal sign in the help like that, that means it's an optional parameter. And if you skip giving it a value, it just defaults to none in this particular case. And so if we round off a number, we don't provide a second argument, then it'll just round it down to the nearest whole number, or round it up as necessary. The return value is an integer if in digits is omitted. Otherwise, it returns the same type as the number was itself. In digits may be negative. That's a trippy thought. Never really thought of that. If you do the rounded version of 1, 2, 3, 4, 5, comma, -2, it rounds it to the nearest hundreds. And if I did -3, it would round it to the nearest thousands. And if I did -4, we would round it to the negative 10,000s. Round 1, 2, 3, 4, 5, comma, -4. Let's prove that. Okay, it's interesting. So the math library, we've already talked about. We can write our own functions. I believe we've demonstrated that before. So typically what they want us to do is start with a comment with the author's name, the purpose of the program, and then include statements that import your libraries that you need. You can initialize important variables. You can prompt the user for input data and save that in variables. You can process the input to produce the results, and you can display the results. A way to run a Python script. Yeah, we're skipping that slide because we're using idle. Python installations enable you to launch Python scripts by double-clicking the files from the operating system's browser. So unless something has gone in, for a while, whenever you installed Python and then you double-clicked on a py script, it launched something called WinPy, which is really aggravating. I believe that they fixed that. If I go here and I try to run my program by double-clicking on it, it actually runs it. And that's good. Something to note is that when I double-clicked it and ran it, it closed immediately. I didn't get to see the output. So here I ran it. It ran the turtle for a while. It drew something on the screen. It all happened so fast I didn't get to see it. And so if that's the case, if you want to be able to run the program by double-clicking on it, and you want to be able to see the results, you need to stick some kind of command in there that'll cause it to wait. The easiest is probably just to do this. That's calling the input function, which does exactly what we want. It sits there and waits. Or we could put a message inside here that said press enter, right, to let them know that they're going to quit it by pressing the enter key. Now that I've done that, I can go to the operating system, double click on the program file, and it'll do all of its business, and then it says press enter. And I can do that. If I leave out that press enter message, it just hangs out, waiting for me to do something. It doesn't tell me what I need to do, but I might be smart enough to know that if I click the close box, it'll go away, right? So if you're going to write software, if you're going to write scripts that you want to be able to run from the user interface rather than from the command prompt, then you're probably going to want to put an input statement at the bottom of it. Pauses to wait for the user to close the window. Do that only if you're going to do it from, if you want these things to run from the command prompt. On the other hand, there's absolutely nothing wrong with putting that there just as a matter of course. It just means that when you run the program by pressing F5, it's always going to wait at the end. And that might get annoying, so I might want to put some actual kind of message there as to indicating what we're waiting to do, right? Press enter to finish, that kind of thing. All right. What I would like for y'all to do in lieu of assigning you homework is, hopefully just about everybody's got Cengage. I would like for you to go and take the Chapter 1 quiz. That'll be the homework assignment rather than me actually give you one. So how are you going to get to the Chapter 1 quiz? You're going to go to Modules. You're going to scroll down to where it says Cengage, and it'll have some nonsense about imported from. I believe yeah. I went into 1113. I'm not going to find what I'm looking for there. Come on. Click on Module, scroll down until you see Lambert Fundamentals of Python. Make sure that you're logged in another tab or whatever before you do this. If you're having trouble logging in, give that a try. And you can either just click on the main link, or you can actually click directly on the quiz link. It should take you to it where you can take the quiz. And then once you take it, you can take it again and get a higher score, and you can take it again and get a higher score. There's no limit on the number of times you can take it, so there's really no excuse for not getting a pretty good grade on it, right? Because you can take it as many times as you need to. Now, I'm not going to run through it with you. Sure seems to be taking a long time to actually launch it. I wonder why that would be.
Yeah. When I did mine, it only took me a couple seconds.
Okay. Well, I'm lucky it's not doing it. Apparently I've forgotten to disable my ad blocks and stuff like that. So anyways, let's make a Dropbox so you can upload a note saying you were here, or upload the notes that you did, and we will be done for the day. And I'll post a note as to the effect that I want you to go ahead and try the Chapter 1 quiz. I don't put due dates on the quizzes, so it's up to your self-discipline to get them done, right? They're worth a grade, so they're worth doing. The reason I don't put a due date on them is so you can take them over and over and get a good grade on them. But that always means that some people don't do them. I don't know how to balance those two things.